Hi students, I thought I'd give you some help over 5.4 derivatives. And so it says to use your knowledge of derivatives to answer this question, and a calculator should not be used. Well, you can use a calculator. I'm going to show you how to do this on Desmos. Okay, so it says that given f of x equals x cubed minus 6x squared plus 9x plus 1, answer the following question. Is the function increasing or decreasing at x equals 2? Well, before you can answer the question, you can look at this graph and see what's happening at 2, but it's better to look at the derivative, and then I'm going to show you how to use the table to tell you what's happening. Alright, so the derivative of the function is 3x squared minus 12x plus 9. Alright, so if we go to Desmos and we take a look at this equation, here it is right here. And to find the derivative, basically all you have to do is go to the function, click on miscellaneous, and the derivative is this d divided by dx. And I'm just going to tell it to find the derivative of f of x. F of x. Now, as you can see, the derivative of f of x, if the first equation was a function of a cubic, then the second equation has to be some kind of squared equation. Alright, so I'm going to take a look at, I'm going to add a table. And I want x1 to just be, let's see, what values that they want us to look at. 2, it said something about, well, we're just going to look at the interval from probably 0 to 5. So I'm going to go 0, 1, 2, oops, sorry, go back up there, enter, 2, 3, 4, and 5. Now over here, I don't want y1. I think what I want, well, what I want is this derivative function. So I'm going to put in d. Okay, so I don't want to put in that derivative function, so I'm going to take this out. Alright, so let's delete that. But what I do want to do is go down here and say that the derivative is 3x squared minus 12x plus 9. So I'm going to say f of x2 equals 3 x squared minus 12x. Let's see what the minus 12x plus 9. Alright. So there's my derivative function. I don't know why it's giving me this. I guess I can delete that. So I'm going to call it f prime of x. There we go. So f prime of x. Alright, so here is the function points, and then I'm going to put in f prime. Back that up. Oh, go to the next one. F prime of x. Let's go with x1. Alright, there we go. Okay, so now we have some derivative points. Alright, so if you look back at the question, it says, is the function increasing or decreasing at x equals 2? Well, if you look at this graph, you would have to say, okay, at 2 is right here, this graph is going down. But if I wanted to know the real truth, I go to my derivative table, and since at 2, under the derivative table, I have a negative value, that tells me that it's decreasing when x equals -2. Okay? So you see these positive values here, 9 and 0, and 0 and 9. Anything below that is probably going to be, it is increasing. And then anything here is increasing. So the only place it's decreasing is right here. Okay, so I'm going to go back. And this table, what is happening? Oh, wow. Okay, let's move that. There we go. So I'm decreasing at 2. Then it says list the intervals on which I was increasing, negative infinity to 1 and 3 to infinity. List the intervals on which f of x is decreasing, was decreasing in between. So that's just 1 and 3. And if you go back and look here, or even here, it is, you see how it goes from 5 to 3, and then from 3 to 1. So in between these values right here, that's the only place the y values are decreasing. So from 1 to 3 is my decreasing. Alright, so if I go back to this list here, it says where, at what values does the function have a relative max and a relative min? Well, if you look at my original function, which is this function, it has a maximum right here, and that point is 1, 5, and then it has a relative min right here. Now the reason we call this a relative max and a relative min is because the real maximum is way up here in infinity, the real minimum is down here. But this little hill, it happens right here. Now, the derivative graph tells you where it happens. A max and a min happens on the derivative graph. This point right here, see how it says 1, 0? Wherever it crosses the graph, it's going to tell you what's happening. Everything on the blue graph that's above, anything that's above the x-axis on the blue graph is positive. Anything below from 1 to 3, that's negative. And so down here is where your graph should be decreasing if you're only using the blue graph. If you use the red graph, just use it. And so you can see. I know it could be the blue and the red, that's more of a calculus thing. So if you don't even want to be bothered with that, you can just say, boom, it has a max here and a minimum there, but you're only supposed to use the x value. So a relative max at 1 and a relative min at 3. Alright, and so once you do that, if you sketch the graph, boom, this is what it should look like. You put your max and your min, then you increase, decrease, increase, and you have the graph without using a calculator. Okay.